To simplify the expression, square root of 3 times a squared times b cubed times the square root of 6 times a to the 5th times b, for our answer, we'll start by just combining, when you have the product here, one root times another. These are both square roots, then we can combine them into one like this. 3a squared b cubed times 6 times a to the 5th times b. Now there's all these times I said times and I didn't write any multiplication signs, but since this is all multiplication, I'll get the numbers by each other, the a stuff by each other, and the b stuff by each other. And then we could even simplify here further with the numbers. Inside the radical, 18 times a to the 7th times b to the 4th. Now, sorry, that radical sign's a little too long there. We're looking for perfect squares. Now, when it comes to a number like 18, 9 is a factor that's a perfect square, and then the rest of that is 2. That doesn't have a perfect square. When you have something in the format base raised to an exponent, you have a perfect square whenever you have an even. Since 7 is odd, we just lower by 1 to get an even. So instead of a to the 7th, we'll have a to the 6th here. Now the issue is a to the 7th is not the same as a to the 6th. So right now we don't have equals. I mean, we haven't written the b yet, but just to account for the a to the 7th, we need to write this as a to the 6th times a to the 1, right? So when you multiply things with the same base, you add the exponents. That 6 plus 1 is 7. That's accounted for. B to the 4th, since 4 is an even number, b to the 4th is already a perfect square, so we'll write that down. This next step, some people prefer to do and some don't really worry about doing, but I'll just go ahead and shuffle how things are written so that the perfect squares are first. And then after this time sign I just drew, the non-perfect square stuff, 2, and then a to the 1, I'll just write a. Let me make that a little longer. That stuff, the 2 times a is not, there's no perfect squares in there. This step is a step that people probably feel okay skipping, but let me just include it, that we can root each of these things separately. So splitting it up like this is okay as long as we have multiplications. And in fact, taking one big root and splitting it up at the timeses, and so just we're multiplying the results of several different square roots, that was what we actually did in reverse at the beginning, right? The multiplying together of two square roots got pushed all into one big one. Now the square root of 9, the square root of 9 is 3. For the square root of a to the 6th, this is a to the 3rd. So what happened is I looked at that 6, said, hey, that's even. If I divide by 2, the exponent is 3, but then I no longer write the square root. So that's the cost. It's like the square root cuts that number 6 in half, right? So the square root of a to the 6th is a to the 3rd with no root symbol. Same deal here. I take that number 4 and divide by 2, so the exponent here is 2. For root 2a, there was nothing that was going to happen in there. So there's our final answer, 3 times a cubed times b to the 2nd times the square root of 2a.